Okay, please let me check that everything is working. Okay, looks good so far. All right. Okay, let's start. Hi everyone. Last time I mentioned about possible new directions of work. Well, we still need to finish our imported monster behavior, and I told about things that should be done next, and one of those is gradual rotation. And I decided to start with this first because I think it requires the most of engineering efforts. It doesn't require any sort of artwork, so I didn't need to create new animations and sounds and projectiles, but I needed to think with my head and solve actual engineering tasks. But first, let me show how it looks like now. So before it rotated uh, towards target instantly. So now it has churn radius, I would say. So see, it takes time to rotate, and it is actually kind of smart. It knows which side to rotate. And now it doesn't rotate instantly anymore. It rotates gradually. And as you can see, it starts to have some sort of churn radius. And even when during chasing, it also like rotates as it goes. Well, it's not really visible right now, but if, for example, if I adjust this thing, it will become more visible, I guess. So yeah, radius is much more bigger now. I see that it still rotates like, yeah, it still needs to like rotate even if it's when it's chasing, but yeah, was kind of radius is not realistic, so let, let's keep it that way. And yeah, let me explain how I did all of that. Well, let's go from here, I guess. Yeah, before this function, it just started animation, because here in the parent class, it where is it? Import, yeah, imported monster. So here it just starts an animation, and here, yeah, it borrowed the method from our debugging monster. So what I changed? Yeah, I just copied and pasted code from there. And here's the change. First, I added this adjust angle, which means like for which angle it may turn per tick. And instead of assigning direction like this, I implemented this function which makes this monster turn gradually towards its target. So let's take a look at it. How does it work? First of all, we need to find two vectors. First vector is direction to target, to the player in this case, and second vector is the direction where the monster is facing at. But we're not really interested in vectors themselves. We are interested in angles. So we are interested in two angles. It's azimuth or horizontal rotation and altitude. And we need to find those angles for two vectors that I mentioned. So first vector is quite easy to get. We can extract it from the monster itself. We know monster rotation. We can get Euler angles from that, and we just assign like this. So rotation around y-axis, which faces up, so rotation around it, it's our azimuth, and altitude, it's rotation around x-axis. For the second vector, meaning direction to target, it's quite more interesting. First of all, let's address this function, which pre-existed. Yeah, we are borrowing it for now. So what it does, it just get a position. It gets position of the target, but it a little bit increases y coordinate. So why I'm doing that? The thing is that actually center point or like registration point of the player is around stomach or chest. But chasing that point doesn't seem reasonable because this is flying monster. It makes sense to just attack head directly. So that's why actually when actual chasing point, it's not the center of the target, but it's somewhere around its head, which is approximately that high. So by default in debugging monster, it was 2.5. For our imported monster, I adjusted that I made it 3. Well, because our flying monster has a little bit different geometry. It has a mouth at certain height, and yeah, just empirically it looks better when it's 3. Yeah, so this function just pretty much gets a target point that we want to chase, which is a little bit higher than actual position of the target of a player in this case, and when we're getting absolute angles. First of all, let's figure out which angles we're trying to get. I mean, yeah, we're getting azimuth and altitude, but between what and what? So those are angles between forward vector, meaning vector with coordinates like this. This is forward vector, so 0 per x, 0 per y, and 1 per z. This is a forward vector, which is facing like forward. So between the angle between global forward vector and between vector that is chasing to the target. And here is actually the same. It's angle between forward vector and vector of direction where the monster looking at. Well, by default, all monsters are spawned facing forward, right? So, and if it rotates somewhere, we are obviously adding some angles to that forward vector. So let's take a look how this function works. It accepts vector of interest and what is happening here. So we have absolutely arbitrary vector in 3D space, and we want to find its azimuth. So what do? We first find projection of vector to xz field. So it can be easily done like that, just assigning y coordinate to 0. And yeah, this is our projection, and we are interested in its length, how long it is. So, and this is how azimuth is found. It's like basic trigonometry, so the ratio between the side and the hypotenuse, it's cosinus of cosine of angle, and like arc cosine, it's angle itself. However, here is the thing, where the arc cosine is agnostic about angle direction. So it doesn't matter if we turned right for 30 degrees or left, value will be kind of the same. It will be the same, or it's just, I mean, this approach gives you absolute angle. I mean, not absolute angle, it gives you like deviation, like, but it doesn't know to the left or to the right. It gives you relative actually deviation, so how much we turned. But we interested in absolute values. So with this approach, you can find angle from 0 to 180 degrees, also known as math pi. But we want, instead, we want it like this, from 0 to 360, or from 0 to 2 pi. So let me yeah. So we want that kind of value. So what we do, if our x is positive, we're assuming that we are rotating towards positive direction. So we just taking this angle that we compute. So rotation to the right, it's positive rotation. We just getting its value, but rotation to the left when x becomes negative, it's a negative rotation. And for example, for projectile, yeah, we just detected the sign and just applied this sign. But now, instead of using sign, we want this notation from 0 till 360, or from 0 till 2 pi. So if x is negative, we get 2 pi and deduct this angle. And so this is how we get absolute azimuth on this range, or on this. And same things actually go to altitude. Again, here is some trigonometry is going on. But again, if we are rotating down, which means that we are rotating, let's say, counterclockwise. No, actually, it's clockwise. Okay, it depends where we're looking from, right? So anyway, so if y is negative, we want to find angle above 180. Like, oh, here's pretty much the same what I just explained. So we're just getting our angle in this range. Because without doing that, we would receive just relative angle, but we want absolute angle, and we want it represented like that. So if we're going to the one direction, we are going 0, 1, 2, 3. If we're going to opposite direction, we're going 359, 358, and this is how it compute. It's actually quite easy, but yeah, it took for me some time to write it more or less short. Yeah, so this is how we get those absolute angles here. So at this point, we know the angle between forward vector and monster monster rotation vector. I mean, okay, this vector between, I mean, these angles are angles between forward vector and the direction of where the monster is looking at, and here are angles between forward vector and the direction to the target. So what we are trying to achieve here, eventually we want those angles to be equal. So when the monster is looking exactly at the target, the angles are equal, and we want gradually increase or decrease rotation in certain direction until those angles matches. So look what we are doing here. First, we need to know the direction of rotation, and we use this function. Let me explain what's going on. Here actually two scenarios are possible. So for example, if we have like two angles, for example, okay, 50 and 60. Okay, so the distance between them is 10. The shortest distance between them is 10 degrees, right? But look what will happen if, for example, we have angles like that. We have 3, 5, 9, and we have, for example, the second one is 1. The actual distance between those two angles is actually 2. It's shorter. Yeah, we could go from 1 to 359. We would get 358 degrees, but it's bigger than rotating around the 0. So because it's a circular, right? So we have angles going like this, 359 and 360, or also 0, right? And where it goes 1, 2, and 3. And between 2 and 3, the shortest distance is obviously 1. We just need to deduct from 3 and 2. But for some angles, it makes sense to go other way, is to jump around the 0. For example, distance between this and this is just 2 degrees. And if we go all the way here and all the way here, it will be bigger. This is not what we want. We want our monster to churn always the most optimal direction. In other words, we want it to churn always like towards target, not into opposite direction. So this is why I use this function, get shortest distance between angles, and it's actually pretty simple. We're returning the shortest distance, the minimum, between two things. First is absolute angle. It's absolute difference between angles. It's for our example, it will be, for example, if we have 359 and 1, it will be 358. But our thing that we're trying to do is to jump around 0, around midnight. So what we do, actually, we get this angle 1, which is 1, for example. And second, we get the full circle, math pi, and we deduct angle 2. So, for example, we have 359, so 360 minus angle 2, we get 1, and we sum these things. So we sum 1 plus 1, we get 2. And 2 is obviously smaller than 358. So in this case, like 2 will be shorter distance. Okay, I said too much things, probably it's hard to follow, but let's recap. This function serves to get the shortest distance between angle, and it might be distance of natural. It might be like natural difference between angles. We are just deducting one angle from other, or it might be a distance around the zero. It might be shorter in some cases, like we just saw. And this function just compares that. What is natural distance between two angles and what is the distance if we go to other direction, meaning we're going around the zero. And the shortest distance is returned. This is how we know which direction we want to rotate. And now here, so we're getting shortest distance between these two vectors, two input vectors. And if it's lower than our adjust angle, we just assign the target angle. Why we do this? We don't want overturn, because our goal is to turn gradually using this adjust angle. So for example, on each tick we turn for 10 degrees, for example. But if angle between these two vectors is lower than 10 degrees, we don't want to churn too much. We don't want to churn to 12 and more. We want to stop at the target angle. We don't want overturn. That's why here is such condition. If the difference between angles is lower than adjust angle, we just assign the target angle. And now here is a simple branching logic. What we can do, we can either add adjust angle to our first angle, either we can deduct it. And we see when we actually get best result. So it kind of a greedy approach, right? If we add adjust angle to current angle and the difference between start angle and target angle reduced, then we are doing right thing, we should add. However, if this gives a bigger distance than this one, than deduction, that means that we need to take this route. We need to deduct. So here we're basically testing what makes us closer to the target, adding a just angle or deducting it. So in other words, does the rotation this direction makes us closer to the target? If yes, yeah, we are adding. If not, if deduction actually makes us closer, we are deducting. And we're doing the same for altitude. So here we are doing for azimuth and here we are doing for altitude. When this was for debugging purposes, initially I thought that I actually need to convert angles back to positive and negative, but actually it's not necessary because sine and cosine and tangent, they actually calculate values right for angles that are higher than 180 degrees. So we don't actually need that. So we can use absolute angles here, and it is able to construct a correct vector because, for example, the cosine of angle 270 and minus 90 is the same. So that's why we can use still absolute values. So we actually don't need this. Yeah, so we got our new angles into the right direction, adjusted by this adjust angle value, and we want to assign this new direction and turn to it. Well, that's it. This is how it works. Well, conceptually, it's not hard actually. So we're getting angles of two vectors, and we're trying to decide which direction is more efficient, and we're turning that direction. We're just adding adjust angle to the right side, towards our target rotation. That's it. But as you can see, it involves some geometry, and yeah, it just took a bit time to think about it. That's why I did that outside of the stream, but I'm explaining everything now. I hope you understand how I did this. If no, then you can ask your questions, but be sure that you refreshed your knowledge about basic trigonometry, about like sine, cosine, tangent, about this like Pythagore theorem. If you know that, there is no problem to understand this because I'm not doing anything like too complicated here. It's basic like geometry from school level, from maybe secondary school. Yeah, and we get what we want after that. So let maybe change this. How to name it better, maybe turning angle, and I will put it somewhere here. Yeah, I think this turning angle. I think it's pretty explicit. Okay, and probably here I will go like this as well. I think it sounds better. Let's take a look that we didn't break anything. Yeah, as you can see, it always chooses the right direction. Well, what does it do now? It's changing direction gradually while proceeding that direction. So I guess we don't need this anymore as well. And now what I actually want to do today and what I want to add to this. As you can see, it stops when it's attacking. I want to make it more evil and I want it to attack on the goal. So here is the main problem. Of course, we can just call this function during the state of melee attack. But the problem here is that it will go in the conflict with chasing animation. We will have two animations at once, chasing animation and attack animation. So what I actually want to do, I just want to call this part, but without this one. I actually want to stop animation. And this is how we can do it. We can just change the function. So proceed direction. So I think I can try to put it here. So we proceed in direction, we are adjusting our angle, and yeah, this proceed direction is just turning to direction and just continues. In fact, if we call turn to direction here, probably we don't need to call it here, I think. Let's see how it goes. I think it should work fine. Oh no, it stopped working. Is it working now? No, it's not the problem. It does the wrong thing. Chase is doing proceed direction and proceed direction. Yeah. I'd return either false or okay, I understand why. Okay, then we need to do some sort of composition here, I guess. Okay. So yeah, because this returns true or false, and we want are we actually reading it from somewhere? Wondering. And maybe here. Okay. Okay, then I can actually do what I wanted to do. So like this, and okay, like I guess it doesn't affect anything. And we actually can do our way. No. If this instance not that and target visible, yeah, we're doing this. Okay, let's try that way. Okay. And in fact, turn to direction by angle. Okay, it still should work. Yeah, so, and yeah, all right, more or less. So now we do this. And we have stop chase, like stop animation. So we want to stop chase animation when we going into attack state. So range attack. So this stop chase, but we still do this proceed direction. And the same goes here, I guess. Yeah. So we're stopping chasing animation, but we keep moving while attacking. It's actually stop moving. Did I save? Stop chase, it's just, okay. It should start range animation. Yeah, it does animation, but it's not proceeding. Why it's not proceeding? Target visible. Probably we don't pass this thing. Let me see. I will restart to have more health for experiments. It's still shaking at the beginning. It has some conflicts. Okay, so proceed direction. Okay, okay. False, target visible. Okay. It's shaking at the beginning, which means there is a conflict of animation. Okay, let's try to figure out what's going on here. Why it's stopping. I want to get here only when, well, only during attack. Okay, so let's try something. Okay. So here, want to go here. Okay. Okay. Go here. So is chasing is blocked here. Okay, this direction exists. Turn to direction, try to move through. Okay, it's through. Okay, okay. Okay, it's actually looks like it should move. Okay. It should be working. At least I don't see any like obvious reason for not to work. What's going on here? Chase animation. We stop calling that for sure. And stop chase. Okay, stop. Okay. That's really strange. Why it stops? Why it stops? Okay, let's oh, I have something unsaved actually. Okay, let's investigate that one. Again, I want to go here. So here when we range attack, we change state. Okay. We're stopping chase. Okay. And I want to rerun it from the beginning. Okay. So, and what I want to do, I want to be sure that we never ever go here again. And actually don't. Okay. Okay, maybe this like stop function doesn't work properly. I don't know. Animation helpers. So stop function stopped true when we stop true and if stopped. Okay. Uh, Probably we have problem here. But we should remove it from handler, I guess. From observable, sorry. It's like trying, it looks like it's trying to play two animations at once. Okay, it'll take a while, I guess. Mhm. Okay, let's, I don't know, try stupid solution. Maybe it would help. I could probably think better, but I'm lazy to think. Mhm. No, it doesn't work. I noticed that it happens only if it goes to attack state very early. Okay, it's definitely problem to think. I will spend hours trying to fix this. Okay, let's try something else. Let's try to see why it stops. So normally here it calls chase, but here it probably I know. Probably I know. Oh no, actually it just runs animation here and no, my guess was wrong. So here it just launches animation and proceeds constantly. When we switch state, it stops animation but still like proceed. But the thing is that it doesn't move when it's like shooting. The only thing that we're calling here is this one. So it doesn't stack, so it always like return true, I guess. So it's just, yeah, turn to direction. Why it stops. Okay, for example, if I still will call just chase here. Okay, will it solve problem? Yeah, it obviously will have that animation collision, but I'm wondering if it will not stop moving. Well, actually, on last shot it was on move. Okay, let's try something else. I have an idea. What if I will just not start? Animation. So It's already actually called stop chase. So we don't need this, but okay. So what if I will not start secondary animation? Will it shoot on the fly? Okay, it doesn't fire, but okay, animation finished, do range attack. Okay, but it stops moving. I don't understand. Yeah, okay, we actually don't need stop chase because it's called above. Okay, it will not shoot right now, but it should not stop. Oh no, it's shooting. Range attack. Oh yeah, I restored that. So yeah, stop chase just disables animation. It doesn't prevent calling the proceeding of direction. I can do even this. Okay. I wanted to change state, but continue following. No, it freezes in place. I don't understand why. Mhm. Just launches animation. Okay, here just proceed direction. It's actually moving, I think. I don't know what's going on. It never returned false, so it's not blocked. Okay, so it definitely continue calling this function even if it's on another state. So it should be going. should, but it doesn't. I don't know, let's try with. Okay, I guess I need more deep experiments with that because according to the code flow, it works fine. It should be moving. I don't know why it stops. Let me see. Maybe. Okay, progress state. Okay, range attack. Proceed direction. And here, I, do we call? Yeah, we call like parent state. So we go in here. Monster. Okay, range attack. Okay, stop chase. Yeah, it's stop animating. That's right. And yeah, we don't really perform attack here anymore. So range attack, this is never called. The only thing, so it just start doing this. Okay, let's try this, I guess. Okay, now it obviously will stop. And now it's stopped for attack because we don't call proceed direction. Now we call it, and it should continue going. It's actually going, just slower. But sometimes it stops. Okay. What if we will not call this thing here like chase? Yeah, here just return. So now it's not animated while moving. So it's still shaking even if I'm not calling animation at all. I don't even start it. So don't even start animation, but it's still like doing weird things. Yeah, yeah. And at some point it stops. Hmm. Huh. There's definitely some failing condition somewhere. Like, but where? Okay. Okay, okay, okay. Okay. False. Okay. Is target visible? Why it get false? Target visible. Okay, something is here. Okay, obviously this thing is failing. And okay, is target visible? Is line of sight? This position, target position, target name, blah blah blah. Okay, let's debug this. There's definitely something wrong. Um, else debugger and okay. 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 So origin position, target position. Okay, for example. Okay, so direction. Okay. Hit. Oh, okay, it's failed casting, but doesn't explain why it stops. Yeah, because I'm moving and yeah, sometimes he casting the ray when I moved somewhere like to the left and it missed me, but doesn't explain. Okay, it didn't work here, but it's not the reason. It's failing somewhere here, but where? We see that blocked actually is never called. I don't know, it's something really, really deep. I guess I will spend hours to debug it because from code flow perspective, everything is correct. Well, it seems like everything is correct. But I don't know what's happening very deep inside. And definitely, and with shaking at the beginning, it's actually also not an animation collision because we disabled animations. There are some uh, simultaneous position rewrites happening from somewhere. I really need to debug it more properly. So for now, let's revert what it is. So it's still working. I mean, the first goal is achieved. It makes it like turn. So it's turning gradually. Next thing I want to do, it's actually kind of optional. I want it to shoot on the fly. Actually, it's still chasing very well, so it can go around obstacles and still having those like turn angles. I mean, first goal is achieved, so we made this thing turn gradually. The second thing what I'm trying to do is to shoot on the fly without stops because those seems kind of weird. I want to proceed direction during that state, but something going on. Something going on. Maybe it goes from here. No, it doesn't do anything. Ah, no, it's not the reason. Yeah, it dumps like rotation here, but I don't know. Maybe I need to address this experiment. Maybe it's the reason, but no, we had that problem even if we didn't actually shoot. We blocked this call and it still had such problems. This is never called because we don't call super state here. Yeah, we go only here. Now it has its own method from here. So it's not that we're calling something from here. It might be some of my animation glitch, I guess. I think I need to debug this stuff instead, which will be kind of hard. But I guess I will check it on my own because it's already too much time. But the first goal is achieved. It's actually like turning smoothly, and this is what I was planned in the first place. But figuring out that unwanted stops when we don't want them, yeah, it's another thing. I want to dig into it. So yeah, I guess this is what I will try to figure out before next stream. But if not, we will probably try something else. Okay, let's see what we did overall. Here I just put this daemon to other location, which you just saw. That's fine, nothing interesting here. Here, these things, this I think I explained really well. It just chooses direction where to turn and turn appropriately. Here I just yeah, proceeding direction and adjusting. Maybe you know what? I think maybe we should separate it because here we're not really like proceeding. Turn, and I will do like we want this only when we're chasing, and let's just do another function like maybe something like that. If it's like time to turn the target, yeah. Let's try this. I think that's better. Yeah, let's keep it that way, and later I debug more. Here, okay, that's unnecessary. All right. To target, I think. I think that's more correct. So target, yeah, something like that. All right. So our remaining plans for this imported monster is to try debug and fix this thing. Then I want to change projectile to something like fireball. Also, I want to add alert animation and also new states and add some sounds to that. And after that, we are done with establishing a pipeline for imported monsters, and we can add more in the future. Yeah, this is what are we going to do in upcoming streams. I hope I will be able to provide something before next week. If not, probably we'll skip a week, but I hope it will not happen. Anyway, hope to see you soon. Have a nice upcoming week. Thank you. Bye.